Two steel plate 120 mm wide and 12.5 mm thick are joined together by means of double transverse fillet weld as shown in figure. Allowable tensile stress for the weld is SYT is given as 110 Newton per mm square. Find the length of the weld if the strength of the weld is equal to the strength of the plate. You have to find out here first what is the strength of the plate. For that one he has given the tensile stress. So strength of the plate will be same as equal to the width of the plate multiplied by the thickness multiplied by tensile strength of the plate. So we'll show the top view here. So we have given here two plate. The one plate will assume equal to width is equal to 120. So we have width is equal to 120 mm. And we have thickness. Thickness is 12.5 mm is same as our leg size. Length of weld we have to find out. Allowable tensile stress for the weld is 110. That value same equal to the strength of the plate. This time the plate will fail by tensile stress. So we have given the value of SYT is equal to 110. Newton per mm square is same as megapascal. This value you have to use for plate as far as weld also. But in the case of the weld we have to use the value of SYS. So we'll take the value of SYS is equal to SYT divided by 2. So SYT is equal to 110 divided by 2. So we have SYS is equal to 55 megapascal. This value of shear is purely for weld. So this time since the force is perpendicular to the width, so the plate will fail in tension. So maximum safe force we can apply if the plate will not fail in tension will be F is equal to the area perpendicular to the force is W multiplied by thickness T multiplied by SYT. That is we have W is equal to 120. Thickness is same as equal to H. So H value and thickness they are same value is equal to 12.5. And we have SYT is equal to 110. Using this we can calculate the maximum safe force which come out to be 165 into 10 to the power 3 Newton. Now same force you have to apply for weld also, and the weld will fail in shear. So whether we have a transverse or parallel fillet, failure is always by shear. In that case we have F is equal to tau. So this time I will use the value of SYS multiplied by the total area 80, that is A total. So we have tau. Since we have double transverse, it is multiplied by 2 multiplied by T multiplied by L. That is equal to tau multiplied by 2 for double transverse. Thickness T we can write the throat thickness here. So already we have used the T for thickness, so I will write here throat multiplied by L. Throat is same as equal to 0.707 multiplied by H. H is same as here equal to 12.5 multiplied by length L. Tau you have to use as same as SYS as the maximum permissible value. So we have tau is equal to 55 multiplied by 2 for double transverse multiplied by 0.707. We have leg size equal to 12.5 multiplied by length L, and we know the safe force we can apply is equal to 165 into 10 to the power 3. From this we can calculate the length of weld required. So in this case we require a length of weld is equal to approximately equal to 170 mm. So out of 170, 85 mm will be on this side and 85 mm will be on this side. So total 85 plus 85 will become 170. A plate 75 mm wide, 10 mm thick is to be welded as T-joint to another plate by means of two parallel fillet welds. If the plate are subjected to static load of 78 kN, allowable stress, that is the shear, is equal to 144. Weld length mm we have to find out. So we are making here T-joint. So we have a plate here and we are making a T-joint here. We have double fillet here. We have given the width of the plate is equal to 75 mm. So we have W is equal to 75 mm. So we have thickness 10 mm. Thickness of the plate that equal to leg size H is equal to 10 mm. So this value is same as equal to H, as well as this value is also equal to H. And the applied load is equal to 78 kilonewtons. So, and the shear strength is given as 144. So we have given the value of F is equal to 78 kilonewton. And the value of tau you have to take as 144 megapascal. So whether you apply the load on the along the axis or perpendicular to axis doesn't matter, because for transverse and parallel fillet, failure is always by shear. So we have force F is equal to shear stress tau multiplied by total area resisting the shear is same as equal to tau multiplied by double transverse. So we have 2 multiplied by the throat area is given as T multiplied by L. That is, we have tau multiplied by 2. T can be replaced as 0.707 times H multiplied by L. We have given the value of force is equal to 78 kilonewton. So we have 78,000. Value of shear stress is equal to 144 multiplied by 2 multiplied by 0.707 times H, which is equal to 10. Leg size. Length we have to find out. So if you solve it, you will get the length L, and the length of weld is close to 38.2 mm. Since we have given the width is equal to 75 and the length of weld is 38.2, so this value is less than 75, so this welding is possible. A steel plate of 100 mm width and 10 mm thickness is welded to another steel plate by means of double parallel fillet weld as shown in figure. Axis of the weld and the direction of force are parallel, so this represents the double parallel fillet weld. The plates are subjected to static force of 50 kilonewton. Determine the required length of the weld if the permissible shear stress in the weld is 94 Newton per mm square. So the leg size in this case will take as the same as the thickness of the plate, which is equal to 10 mm, and we have shear tau is equal to 94 Newton per mm square is megapascal. So this one is a case of a double parallel fillet weld, and we have transverse or parallel, both will fail by shear. So we have force F is same as equal to shear stress tau multiplied by 2 times of throat area, that is T multiplied by L, 2 for double parallel. So we have F is equal to tau multiplied by 2. Throat is replaced as 0.707 of leg size H multiplied by L. This time the value of F is equal to 50,000. Tau is equal to 94 multiplied by 2 multiplied by 0.707. We have leg size is same as thickness of plate equal to 10 multiplied by L. L is the single parallel. So in this case we will get the length L is equal to 37.6, that will be in mm. So as shown in figure, we have required length L will be equal to 37.6 mm. The allowable load per mm length of a parallel weld for a permissible shear strength of 94 megapascal, and we have weld leg dimension, that is leg size equal to 8 mm, we have to find out in Newton per mm. Since we have given here the parallel fillet, we have F is equal to tau multiplied by the throat area A, that is we have F is equal to tau. Throat area is given as throat thickness T multiplied by length of weld L. We are interested to know here F by L, that is the allowable load per mm length. So we have F is equal to tau. Throat thickness we can replace as 0.707 multiplied by leg size multiplied by L. So in this case we have F by L is equal to tau multiplied by 0.707 multiplied by H. Here we have shear stress is equal to 94 megapascal and the value of leg size equal to 8 is multiplied by 0.707 and we have leg size equal to 8. This answer is very close to 1064 Newton per mm. This unit is analogous to UDL, uniformly distributed load. A plate of 100 mm wide, 12 mm thick is to be welded as per the alternative shown here. We have given here two cases, case 1 and the case 2. In the first case, we have the parallel fillet weld of equal length equal to L subjected to force equal to F. In the second case, we have transverse fillet of length equal to L and the same force equal to F. Which joint should be recommended for the use if the applied load is limited to 80 kN and the weld length equal to 115 mm? The permissible shear strength is 56 megapascal and the tensile strength equal to 70 megapascal. Now since this one is a case representing the double parallel and this case represents the double transverse. So whether we have a transverse or parallel fillet, the failure is always by shear and we have to take the value of shear is equal to 56. So that value is remains same. Even the value of force is remains same. We have total area is 2 times of throat thickness T multiplied by L multiplied by tau. So neither the value of throat thickness will change, the length of weld will not change and the value of tau will not change. So both of these cases will be suitable for us. So anyone you can select. Either you can select the double parallel or you can select the double transverse because this answer is remains same. In the figure, a plate is connected to another plate by fillet weld around the ends and the inside machine slot. So this one is a machine slot of 60 mm by 20 mm and it is welded all along the periphery. And plate 1 and plate 2 are welded along 120 mm parallel to the force F, that is a longitudinal, as well as 120 mm longitudinal and one transverse that equal to 120 mm. So this one is a combination of a transverse as well as parallel fillet, which one is called as a longitudinal fillet. The working stresses for the transverse weld, that is this stress is a transverse, this one is a transverse, this one is a transverse, is 102.5 megapascal and longitudinal weld is 84. This one is longitudinal, this one is longitudinal, longitudinal and longitudinal because the axis is parallel to the force is 84 megapascal. The joint is subjected to a pull of 100 kilonewton. The size of the weld, that is the leg size, we have to find out. We will first identify which one is a transverse here. The axis of this weld is perpendicular to the force, so this one is a transverse. As well as axis of this weld is also perpendicular to the force, so that is also transverse. As well as this length is also transverse. So this one is also transverse. So let's call this one is L1 and this one is L2. So 2 times of L1 plus L2 is a total weld length in a transverse. So we'll calculate the total weld length for the transverse. Let represent as LT is this length, which is equal to 120 is L2 plus this length, which is equal to L1 plus this length, which is again equal to L1. So we have a value of L2 is equal to 120, L1 is equal to 20 plus 20. So 20 plus 20, 40 plus 120 is equal to 160 mm. And tau 1 represent the working stress for transverse weld, which is equal to 102.5. So we have tau 1 equal to 102.5 is megapascal. So corresponding force F1 will be equal to tau 1 multiplied by throat area T multiplied by the length size equal to LT. Secondly, we have to find out the total weld length for longitudinal weld. So this length is a longitudinal length. Let's call it as L3 length. Similarly, L4 is same as equal to L3. So L3 is also longitudinal. Even the axis of this weld is parallel to its longitudinal. Let's call it as L4 plus L4. So this length is also longitudinal. So total length for longitudinal equal to LL is equal to L3. This one is also L3. So it is multiplied by 2 plus L4, top and bottom both. So we have 2 times of L4. We have L3 is equal to 120. So we have 120 multiplied by 2 plus we have 2 times of L4, that equal to 60. 120 plus 240 is equal to 300 mm is the total weld length for longitudinal weld. And we have tau 2 is a working stress for longitudinal is equal to 84 megapascal. So we have 84 megapascal. Corresponding force will represent as F2 is equal to tau 2 multiplied by T, throat thickness, multiplied by the total length equal to LL for transverse loading. F1 plus F2 is same as equal to F. So we have F is equal to F1 plus F2. That is same as equal to tau 1 multiplied by tau 1 multiplied by T. The length required for transverse loading is equal to LT plus we have tau 2 multiplied by throat thickness T multiplied by the length required for longitudinal, that is LL. We have value of F is same as equal to 100 kilonewton. So we have 100 10 to the power 3. 1 you have to take as 102.5. 102.5 multiplied by T. The LT value you have to take as 160 plus tau 2. Tau 2 is equal to 84 multiplied by throat thickness equal to T, and the total length in the case of longitudinal equal to 300. Solve this, you will get the throat thickness first. So we have throat thickness equal to 2.12 mm. The throat is same as equal to 0.707 times the leg size. You have to always give the leg size here. So we have H is equal to 2.12 divided by 0.707 is very close to 3 mm. So in this type of numerical, you have to identify the weld axis. Whether weld axis is parallel, then it's a longitudinal or parallel type of weld, and if the axis is perpendicular, then it's a case of transverse loading. Find out the total length of the transverse plus the total length of longitudinal. Find out the contribution of force due to transverse and longitudinal. Finally, we have total force is equal to F1 plus F2, and then you can find out thickness, or you can find out the size of the leg. A steel plate of 200 mm wide and 5 mm thickness. So thickness will be same as equal to leg size. With another steel plate as shown in figure, the permissible tensile and the shear stress for the weld material is 80 and 60. Tensile is of no use. You have to only use the shear, because failure is always by shear, whether we have a transverse or parallel fillet. The plate are subjected to force of 80 kN, then the ratio of the strength of transverse fillet weld to the double parallel fillet we have to calculate. So axis of this weld is perpendicular to the direction of force, so it's a case of transverse fillet. And the axis of this fillet is parallel to the force, so this fillet as well as top fillet is a parallel fillet, so we'll call it as a double parallel. The transverse has a length equal to L1, so length of transverse fillet is L1, and the double parallel length is equal to each of them is equal to L. Since here the transverse as well as double parallel both will fail by shear, so you have to take the value of tau only, and we have value of shear stress tau is equal to 60 megapascal. 60 megapascal. And we have leg size H is same as equal to the thickness of the plate, that equal to 5 mm. The total weld length for the transverse fillet is equal to L1. So we have L1 and we can record the value of L1 from figure is equal to 200 mm. Let's say corresponding force is equal to F1, which is equal to tau multiplied by throat thickness T multiplied by length equal to L1 is same as equal to tau. Throat thickness we can write as 0.707 multiplied by leg size H multiplied by L1. Tau value you have to use as 60 multiplied by 0.707 multiplied by H, that is the leg size equal to 5, and we have length L is equal to 200. So we get F1 is equal to 42420 Newton. That is we have 42.42 kilonewton. Suppose we say F2 is the force carried by double parallel. We know that the value of F will be distributed in the transverse plus parallel. Where value of F is given as 80. F1 is equal to 42.42. So we can calculate the value of F2. So in this case we get F2 equal to 37580 Newton. That is 37.58 kilonewton. So we know F1, we know F2. We are interested to the ratio of the strength of transverse fillet, that is F1 divided by the double parallel fillet, that is divided by F2, which is same as equal to F1 is 42.42 divided by 37.58. So this ratio come to 1.13. The video you are watching is from the app, which is the Mohod class app available on Google Store. And in this app, we'll cover all subjects involved in mechanical engineering for GATE. Join the course directly from your mobile. The link is given here.